All right, with 8.2, the formulas are given to you right there, right at the top. Okay, so we're talking about double angle formulas. You saw an example in the homework the other day of sine of 2 theta, and we changed it to sine of theta plus theta, and we used the idea of the addition formula for it. Okay, but now we can just leave it as sine of 2 theta if that's what we want to do, and our formula is given to us. It's 2 sine of x, cosine of x, so on and so forth. All right, with our cosine and tan. All right, so big idea for today is if they only tell us what sine is, you need to calculate what cosine is or tangent is on your own so that you can go and plug them back into the formulas, okay? And that's the same thing that we were doing the last couple of days, you know, like if you remember Zoe's question from the other day, like how did you know or why was it important that it was in the third quadrant, etc. Okay, so remember, you're given something and you need to use it in order to find the other pieces. Okay, so for example, using the given information to evaluate each of the following, okay, the very first thing I would do is knowing sine of x is equal to 4/5, I would try and figure out what cosine of x was first and what tangent of x was. Okay, so reminders. We've talked about this over and over and over again. We can either do sine squared plus cosine squared equals 1 to figure out what cosine is, or we can draw a picture. What do you want to do?
I want to draw a picture.
You want to draw a picture, okay? All right. So what quadrant is it in? It's in the second quadrant, okay? So if I draw my triangle in the second quadrant with the right angle, remember, always going to the x-axis. Okay, we've got our x here. So where would I put the 4 from sine of x, and where would I put the 5? Say again?
The 5 is the hypotenuse.
5 is the hypotenuse.
And 4 is the
Up and down, the opposite. Okay, so therefore we need to figure out the part on the x-axis. And if you remember yesterday, one of our Pythagorean triples, it'd be 3. Is everybody okay with that? Go ahead.
We can like do the like Pythagorean beyond in their head, like if
Yep.
it's gonna be squared. Do we have to like draw it out?
No.
Okay.
Nope. So like, yeah, I didn't draw a picture when I was doing the notes. So
Okay.
yeah, I knew it was 3, 4, 5, but I knew that it was a negative
Yeah.
3 because it's the second quadrant. Okay. So now we know that cosine of x is equal to a negative 3/5. What is tangent of x equal to? Negative 4/3. Okay? All right, so now, once we know what those pieces are, honestly, for today, it's really just going to come down to just plugging and chugging, because sine of x is equal to 2 times whatever the sine of x value is times the cosine of x value. So in our case, that is 2 times 4/5 times cosine, which we just figured out is negative 3/5. Multiply across, and we're done. If you need to, put the 2 in terms of 2 over 1 and multiply the numerators, multiply the denominators. So what's 2 times 4 times negative 3? Negative 24. What's 1 times 5 times 5? 25. Okay? It's probably easier than typing it in your calculator. Okay? All right, so cosine of x is a little bit more complicated only because you're going to be doing some squaring. It's cosine squared x minus sine squared x. So now that we know what cosine is, it is negative 3/5 squared minus a 4/5 squared. For some reason, and so I just want to make sure I talk about this, when we were doing this back in chapter 6, some of you, when you were squaring, you were keeping your answer negative, okay? But what happens when you square a negative? It becomes a positive, okay? So if you square the top and square the bottom, 3 squared and 5 squared becomes 9 over 25. Square the top and the bottom for the 4/5, you get 16 over 25. And what's 9/25 minus 16/25? Negative 7/25. Yes, go ahead.
I have a question. So what would change if the 2 like squares on the outside of the
if the 2 was on the outside, like it was says cosine x quantity squared,
Yeah.
not much really. Yeah, it would be, you know, you would figure out what your cosine of x value is, and then you would square that value. Yeah. Last one, tangent of 2x. So again, just plugging into our formula. Okay, we would have 2 times tan x over 1 minus tan squared x. So tangent we already figured out, so it's 2 times negative 4/3, all over 1 minus a negative 4/3 quantity squared. All right, so you're probably going to end up with a fraction in the numerator, fraction in the denominator. Remember that all you have to do is take the numerator and multiply by the reciprocal of the denominator. What's the numerator become? Negative 8/3 is correct. Okay, the bottom, remember that this is 1 minus a 16/9. 1 is the same thing as 16 over 16. So what's 16 this is 9 over 9. What's 9/9 minus 16/9? Negative 7/9. So if I go ahead and multiply by the reciprocal of negative 9 over 7, what do we get for our final answer? And remember, you can cross simplify. 3 goes into 9 3 times, and now your numbers are smaller. Hopefully you're going to give me a positive answer as well.
72 over 21st.
Oh, well, I simplified that. So 72 and 21 are both divisible by 3. So what's 72 divided by 3? What's 21 divided by 3?
72 over 3.
24 over 7. So Sean, the easier way to do it is if we do the cross simplifying. 3 goes into 9 3 times. 8 times 3 is 24. And then you've got 1 times 7 is 7. Otherwise, just simplify. Okay? Does that sound hard? No. Okay. So if you go to the back side, the only difference here is they're just going to change up, you know, like what they give you. Okay? So it looks like they gave us tangent of x. They still give it to us in the second quadrant. So if it is helpful, we can always go to the idea of drawing a picture. All right, so we're drawing a picture. We're in the second quadrant. We've got tangent of x is equal to 8/3, which is opposite over adjacent. Something's wrong there.
Yeah, how is it not negative?
Yeah, it's got to be negative. It must be a typo. Okay, so we'll make it negative 8/3 and then make that negative 3. Okay? All right, so very first thing that you would have to do is just figure out what your hypotenuse is. 8 squared plus 3 squared. 8 squared is 3 squared is 64 plus 9 is 73. 73 is prime, so therefore we have the square root of 73. Okay? And then remember, the whole purpose of that is so that you could figure out what sine of x is and what cosine of x is. That's a good question. You know, I was not going to, and there's going to be a reason why, and I can show you why that is in a second. So that's a great question. What is sine of x? 8 over square root 73, and what's cosine? All right, and here's why I was not going to. Take the time. Okay, sine of 2x, isn't that 2 sine of x cosine of x? Right? Okay, so like like chess, I'm always thinking a move ahead. Okay, so 2 times 8 over root 73 times negative 3 over root 73. Well, what happens if I take root 73 and multiply by root 73? It's just 73 in the denominator, so do I need to take the time to rationalize? I didn't think so, okay? So that's a great question, all right? And so now we just got 16 times negative 3, which is negative 48. And 73 is prime, so we can't simplify, okay? All right, and then even with the cosine, remember, isn't it cosine squared x minus sine squared x? So what happens if I take a negative 3 over root 73 and I square that? What's going to happen to our radical? It's going to cancel out, right? Okay, it's just going to become regular 73. And then the same thing with the minus of the 8 over root 73. So you're seeing how you probably do not need to rationalize because the formula is going to take care of it. Okay. So now what do we got? 9 over 73 minus 64 over 73. So it's 9 minus 64. About negative 55? Negative 55 over 73. Okay. Questions there? Anybody? No? Okay. So understand, you know, to like, think about, you know, I didn't really get into details with this a whole lot, okay? But our x value is somewhere between 45 and 90, right? So like, it could be 46 and it could be 89. Well, what happens when you double 46? You get 92, which is now in the third quadrant. And if you had an angle that was 89, you would double that and you're at what, 178, okay? So in terms of like, I guess kind of putting this in perspective, you know, your doubling of your angles could potentially, you know, change quadrants, okay? And so think about like in terms of your positive and negatives, what that could potentially look like, okay? So just kind of think about that. So the reason why the sine could be a negative 48 over 73 is because if we double any angle from 45 to 90, that means it could go anywhere from quadrant 2 to quadrant 3. So therefore, by doubling, this must be in quadrant 3 now, okay? So just something to think about, okay? All right, tangent of 2x. Did you guys already figure that one out?
Yeah.
What'd you get?
16 over 61.
16 over 61. Anybody else? 48 over 55. Which one sounds more reasonable? Why the second one? Oh. Oh.
Negative 48 over 55.
But what's a negative divided by a negative? Here's something I you know, I didn't point it out earlier, but the only reason I'm pointing it now is because we came up with an answer that didn't show up. Is what is tangent the same thing as sine over cosine? So if we figured out sine to be negative 48 over 73, and we figured out cosine to be negative 55 over 73, wouldn't it make sense that tangent is then 48 over 55, or negative 48 over negative 55, which is, oh, Jake's mind just got blown there. Wow, yeah. So if you do the math using the tangent formula, which I still want you to do, even though I showed you this, okay? And the only reason is to practice it a little bit, you should end up with 48 over 55, okay? I can help you on yours, all right? Questions? All right, so you tell me, do we need to keep going and do example 3? You're good? You got the idea? Okay, so they give you the picture, figure out the hypotenuse, then you know your 3 trig functions, plug, chug, and you're done. Okay? All right, so homework, you've got